Hello everyone, and welcome to today's topic, which is a brief introduction to vertical transportation and service facilities, for us topic 14. So without further ado, let's get started. Well, before we jump in, let's take care of some housekeeping, shall we? You've reached this video as it was linked for you in your course notes, which you found online through our Brightspace page. So if you haven't already, please be sure to download your course notes to your device of choice, rather than accessing them through just our Brightspace page, because you never know when Brightspace may not be accessible this way, okay? Now, for the topic at hand, what exactly am I going to be meaning by vertical transportation and service facilities as they pertain to Section 3.5 and 3.6 of the Ontario Building Code? Well, perhaps this music will give you a hint. That's right. If you recognize this style of music, it is commonly known as elevator music. So then, we will be chatting a little bit about elevators today, among other things. Or in more general terms, we will be looking at the implication from moving people, air, and other items vertically through a building. You see, for the purposes of vertical transportation, we're really talking about what could be considered vertical tunnels going through a building. And when you penetrate through a floor, a roof, or another structural system with these tunnels, you're essentially punching a hole through that structure. Specifically, what I mean is that the integrity of the fire rating may be compromised, or at the very least, we need to be aware of, for the purposes of this introductory code course, of the building code provisions that are required to maintain the fire rating of the building whenever we punch through a floor because of an elevator shaft, or punch through a roof because of air ducts and garbage chutes. So, as a reminder of what these systems kind of look like in our very own ACE building on campus, you can see here I have a view of the indoor 5-story foyer. So here you can see the air duct on the left, and there's an elevator shaft. The two exposed open air elevator shafts are in the middle, and you can see right here how the air duct delivers air to the full 5 stories of the building. Now the arrow is not pointing in the actual direction the air moves, it's just to illustrate the air moves through there. And then you can see on the side of this air duct, there are smaller ones that then penetrate into the walls to deliver air, or take air, from those floors, right? Each one of those stories. Make sense? So you can see how delivering air to a whole building is going to punch through walls and ceilings and floors. Similarly, when we look at an elevator shaft, in a typical elevator shaft with an elevator that's allowed to move vertically through a building, do you see how it makes sense that in a typical building, not necessarily our very own ACE building because it's fully exposed, but in a typical building, that elevator shaft basically punches through vertically through a whole bunch of floors. It's the only way that you can get people to every story if you punch through that floor. So, right? Can you see how it is important to know how to ensure that the fire rating of the whole building gets maintained as you punch through it? Now, let's start with the elevator, okay? If we are going to penetrate the floor with an elevator shaft, we have to make sure that we don't turn that elevator shaft into a chimney. You see, if fire were to get into that elevator shaft, it would be spread through the whole building because it would act like a chimney. So we have to basically understand how to properly rate and protect the elevator shaft to ensure that that doesn't happen. Luckily for us, the way to figure out the fire resistance rating of an elevator shaft, or as it's more properly known, an elevator hoistway, that method is relatively simple because it's very similar to the way we figured out the fire protection rating of closures for the Ontario Building Code. Remember when we covered, I think it was topics 7 and 8. Remember that? So specifically what I'm getting at, if you refer under section 3.5 to table 3.5.3.1 as illustrated here in your course notes, if you reach that table, you'll notice that it's set up in a very simple way for you to come up with the fire resistance rating of an elevator hoistway, as long as you're able to determine the fire resistance rating of a floor assembly. And we spent a fair bit of time, I believe it was under topics 7 and 8, in figuring out how to come up with the fire resistance rating of a floor assembly. So if you don't remember, go back to those topics to look it up. But let's do an example, okay? If you have a floor that's, say, rated at 2 hours, then from this table, if you go and find it, it will tell you that then the elevator hoistway, the elevator shaft, then must be rated for an hour and a half to maintain the fire rating of the whole building, so to make sure it's safe. Or, if the fire resistance rating of the floor is 1 hour, then the rating of the elevator hoistway must be 1 hour, and so on and so forth. Does this remind you of how we did it for enclosures, right? The fire rating of enclosures? Go look it up. I'm sure it will come back to you once you look it up. Now, please also note that under section 3.5, the elevator machine room must also be fire rated properly, as it is important that the machinery that's housing the elevator equipment is also fire rated and separated from the rest of the building. You can find this under sentences 3.5.3.3, 1 and 2. Right. Moving on to then section 3.6, service facilities. This topic, for as briefly as I will cover it for this, deals with very specific rooms and spaces in a building, and how these rooms and spaces need to be fire rated and possibly properly separated from the rest of the building, for a number of reasons. So these include rooms like electrical rooms, mechanical rooms, telephone rooms, air ducts, garbage chutes, garbage rooms, and so on and so forth. For the purposes of section 3.6 of the Ontario Building Code, these rooms are covered by slightly different provisions than the rest of the building. And you can find these details under sentence 3.6.2.11 all the way to sentence 11. I would expect you to go over and read these sentences pretty please. One specific one that I want to point out to you is that in the building code, the word electrical room actually means something different from the words electrical equipment vault. So I recommend you look both of these up. And I'm winking at you, okay? I'm not sure if you can tell. Very well. Moving on to mechanical shafts. If you have a mechanical shaft that's punching through a number of floor systems in a building, it's kind of like an elevator hoistway, right? The mechanical shafts is a big chimney that goes through a building if it's there to deliver air, for example, right? Hot air or cold air. And it has to be fire rated properly to maintain the fire assembly requirements of all the floor systems. For this, you would go to table 3.6.3.1. Once there, that table is set up exactly the same way. as long as you can find the fire rating of the floor assembly you're looking at, then you can go across that row in the table and you can find the necessary fire rating for the mechanical shaft. For example, if you have a 2-hour floor assembly, then the mechanical shaft has to be rated for 1 hour. Or, if you have a 1-hour floor assembly, the mechanical shaft must be rated for 45 minutes, and so on and so forth. If it can help, again, envision vertical mechanical shafts basically as a transportation superhighway that's moving air throughout the building, and that both includes air that's being brought into the building, warmed up or cooled and shared within a whole bunch of the rooms in that building, as well as the air that's being sucked out of these rooms and then expelled outdoors. So typically, as you can see, these mechanical shafts need to be continuous, right? If they operate in this cycle of in air and out air, and they have to therefore be properly built to prevent fire from getting into these shafts, because once the fire gets in there, it can easily spread everywhere. Okay? So, I've included for you an example of a detail of the construction of how a mechanical shaft would be enclosed for fire purposes. I've put this also in your course notes so you can look at it a little more carefully. Okay, I took this from the ULC, and similarly, here is an example of a garbage chute and a garbage room. This too is also reproduced for you in your course notes. If you've ever lived, or you currently live, in a multi-story legal apartment building, you're likely familiar with garbage chutes, right? And these chutes are basically, again, also vertical transportation highways for stuff that you don't want. You know, garbage, right? And if you've ever tried to throw the garbage into these chutes, you know how sometimes when you push it into the chutes, it can get stuck, right? So you can see how it makes sense that if there is ever a fire in that garbage chute, and the garbage chute and the garbage room are not properly fire rated and separated from the rest of the building, that fire can really spread because there is kindle for this fire throughout, right, the chute, right, with all these stuck pieces of garbage. Alright, I want to remind you that the homework is posted for you. So that includes homework 9, but everything else also before this. And all the solutions for your homework is posted. The solutions will become visible as soon as you click and view the homework. I also want to wish you good luck on our upcoming test. I believe it's test 2. I know you're going to rock it, but I also know that it's going to take a fair bit of work on your part to prepare for it, because this test will cover everything up until now. So even everything that was included in test 1. But you can do it. I believe in you. That's it. This was a super quick topic, and I'm gonna wrap it up. I want to thank you so much for your time. I really appreciate it. Take care, stay well, and I'll see you soon.